So, hello, good morning, all. My name is Junaid, and today I am with my professor, Dr. Jordi Serra-Ruiz. And today I will present AI-powered ransomware detection. It's a comprehensive survey on machine learning and deep learning techniques. And my affiliation with University of Oberta, Catalunya, Barcelona, Spain. And I'm working with Kisan Research Lab. Okay, that's good. So today my outline will be context, where I will tell you my objectives, my motivations, and how ransomware will work, and will tell you about the importance of the ransomware and what is ransomware, how it is dangerous for the real life, and then we'll tell you the taxonomy of ransomware. Uh, Here I will tell you what is ransomware and how its types and critical for the for this life era, and then we'll introduce the detection methods. There will be some traditional detection methods and some maybe machine learning, deep learning things. And after that, we'll tell you the challenges or how challenges in detection methods. And then I have surveyed some techniques. So we'll tell you about these techniques, these approaches, these gaps, and performance maybe. And after that, we have some comparative analysis, and then current challenges which we are facing, and after that we have future directions, and then conclusions. So in the context, I will tell you what is ransomware and how it is critical in cyber threat, and will tell you the importance of machine learning and deep learning techniques. My objective will be to compare the various ransomware detection approaches, and and my key finding will be highlighting traditional method, hybrid model, machine learning, deep learning models, current challenges, and future direction. So before going ahead into the importance of ransomware, I will tell you what is ransomware. Ransomware is a type of a malware or a malicious software that encrypts the files or lock the devices, demanding payment for the restorations. Ransomware remains one of the biggest cyber threat. Before going dive deeper, let me tell you how ransomware is so dangerous. I have mentioned some major incidents. In 2017, a WannaCry spread wildfire, and it infecting over 200,000 computers in 150 plus countries. And other is 2021 Colonial Pipeline attack. It paid approximately 4.4 million USD dollars to the attacker, and more it increasing in the health sector, finance sector, government sector. So it's not a tech issue anymore. It's a real world crisis. So we have to protect. We have to detect them. So for the detection system, firstly we should know about the taxonomy, how ransomware works, how ransomware types. So there are three types of ransomwares: the local ransomware, crypto ransomware, and hybrid ransomware. If you talk about the local ransomware, it basically blocks the user accesses and asks for the payment for the password or PIN code. For example, a sample Revaton, and the lastly, if it comes to when it comes to computer, it shows like a police ransomware. It falsely claims the user violated laws and demand payment to unlock the devices. And another is crypto. Crypto ransomware. This type of ransomware normally encrypts your all files, data, and important informations, and ask for the payment for the decryption keys. So, for what is the example? Example is like WannaCry in 2017 attack. Like it encrypted data globally and demand payment for the Bitcoin in the Bitcoins, because Bitcoin is not traceable currency, maybe therefore. And another is we have hybrid techniques. Hybrid technique is more dangerous because it's a combination of local and crypto. It has both features, both functionalities. It comes to your computer, locks your data, and encrypts your all files and information on each. And for example, we have Patia in 2016. It's an example of hybrid approach. It encrypts the file and master, boot, record, and everything, like making the entire system unusable. So if we talk about the evaluation, ransomware is evolving day by day, increasing with the more smarter techniques, aviation techniques, trying to hide themselves, and attackers and hackers are becoming more talented, maybe, and ransomware is growing. So we have to detect them. But for the detection system, firstly, we should know about the traditional detection methods. So in the traditional detection methods, we have some static analysis and dynamic analysis. If we talk about the static analysis, it normally, we can say, without executing the application. We examine the code without executing it. We decompile it. We could decompile the application and find the code and find the, maybe you can expect the source code, bytecode, detect vulnerabilities, coding errors, malicious intent. And if we talk about its advantages, it is fast and scalable. No execution needed, only detection. How it is fast? Because we sometimes without running the application, examine the code is fast and quick method. So we don't need to run the application in a safe environment or something. So useful when don't running, we are not running the application in the real environment, and it would be it would be maybe good for in static analysis. How it is work in the early detection? Early detection means like we can find the malicious thing while development phase and developing the application. We can examine the code. If is there something malicious, we can find error or something like, so uh, we can detect it and can solve it. So there we have some limitations in the static analysis, obfuscation and polymorphism. If you take the obfuscation maybe we can say like changing inside the code. Sometimes we hackers can renaming the variables, confusing the logic, and can add the junk codes inside the code. So it is a smarter trick to bypass the system. And another is we have polymorphism. Polymorphism means change in the shape. So we sometimes uh, it it's change in the code structure and the shape of the structure every time that when it runs, it replicates it and await the static signature and static analysis maybe. So let's see the second method. We have dynamic analysis. In the dynamic analysis, we run the code or application in controlled environment, and maybe we can say isolated environment, sandbox environment, virtual environment. These are the same, and we have some advantages of traditional dynamic analysis. Some behavior insight. Behavior insight mean like monitoring the behavior, monitoring the files, modifications. If there's something change in runtime, maybe changing in the file, and they can assess the networks without the permissions and registry changes, so it can detect it. And second is we have effective against obfuscation. How? It is against the obfuscation? Because running the application in the dynamic behavior, maybe in the isolated environment or sandbox, can reveal the intent. Uh, maybe. So regardless of how the code looks, it can detect how the code looks. Uh, we can't detect in the static analysis, but when it runs in the dynamic in the sandbox system, it can reveal its malicious content. And the third is can capture evasive malwares. Some malwares wait for the specific condition and are met. Sometimes it requires the time, sometimes it requires the button to push it. So in the sandbox, in the dynamic analysis, it can simulate these type of all actions. So we can detect the malicious things. So we have some limitations. In the limitation, Firstly, like it's resource intensive. How? Because require the setup, we require the setup, we require the sandbox, we require the virtual machine or something like. So it is resource intensive. It is sometimes slower because complex malware, because of large sample, we have to analyze the each sample or complex malware in a dynamic condition. It sometimes takes time, so it could be a slower. And third, we have evasions techniques. So malwares, also malwares can detect some sandbox systems. So mm, if it can, the malware can detect it is sandbox, it is virtual environment, so it will not run the malicious things. So of course, the traditional detection method is not longer enough. We have to work on it. So after that, the rise of machine learning, machine learning arise comes in to detect things, and of course it works very well. Data set from it learns from data set and can detect new and unknown ransomware, zero-day detections. It was very well in machine learning. Their algorithm they use decision tree, SVM, random forest, and features somehow they like the effective API call, history, etc. We have two techniques in machine learning: supervised learning and unsupervised learning. If we talk about the supervised learning, it works with the pre-label set, label data set. We have some algorithm random forest, SVG, SVM, XGBoost for the classification, but it works with the label data set. And if we talk about the unsupervised learning, it can work on strange data. It can work on without pre-label level. It can work on new behaviors. So we can say it's anomaly detection. For the anomaly detection, we can we have some clustering techniques, k-means, and DB scans. Okay, so what next? Another we have working with deep learning techniques. We have CNN, RNN, transfer model, auto-encoder. In CNN, it normally useful with the image-based ransomware detection for binary visualization. If we talk about the RNN, it can be useful in sequential behavior. Sometimes when we need to analyze the API call or something like sequence, so it is more balanced with the sequence things. And transformer model, it works well, very well with text, audio, even time series for the hybrid analysis. And if we talk about the autoencoder, it is good for compressed representation for anomaly detections. So machine learning comes in, it works very well, but still it's not a black magic. We still have some challenges. So let's see what challenges evolving ransomware, and some ransomware is getting updated day by day, so it's a real big challenge. They have some polymorphism techniques, some anti-sandboxing techniques. As I talked about the sandboxing virtual machine in the dynamic analysis, it can detect by the smarter tricky tricks. With we will say it anti-sandboxing. And after that, we have some data set limitations. Data outdated data set, limited data set, and not processed data set can be a big challenge in machine learning. If we are working in machine learning and deep learning, it always will be have good results if you have quality data set and larger data set. Low data set and limited data set, maybe outdated data set can be a maybe failure your results and can't detect the things well. So it's a big challenge in machine learning things. That's the third is cost. Of course, if you talk about the real-time detection things, it always requires the high computational cost. Sometimes high GPUs, sometimes processors, things like we would need to detect the real-time detection. Okay, so I have surveyed some techniques, some recent techniques. The first is opcode analysis. In the opcode analysis, we have the approach with supervised machine learning. The strength in this, like we have early detection of the ransomware families, and it is scalable for the real-time deployment and in diverse environment. And in the limitation we have it requires a large and labeled of course data set and performance 97% accuracy, and platform they are using Windows, Linux, and cloud environment. Second is ransomnet. It requires it is working with this approach, deep learning, CNN plus transformer. The strength it has highly effective for the zero-day attack, new ransomwares, and it has 98.5% recall against the zero-day attacks. Limitation has high resource cost and limited to a cloud platform. So performance metrics will have 99.5% precision, and cloud it is limited to a cloud environment. Okay, the third we have deepware. This approach is working with deep learning, HPC plus RNN, and strength. So maybe you can say it's a real-time detection and detect hidden malware. It is very good in anti-sandboxing. If the attackers use anti-sandboxing smarter tricks to bypass the system, it is very well working with. And the limitation we have, it requires HPC support, platform dependent. It is like only work with enterprise or high performance computers, and performance like it has good performance, 98.6% recalls. Another is BTLS algorithms. Approach they used hybrid static plus dynamic machine learning, and strength it was very optimized the polymorphic and aggressive ransomwares. And if we talk about the limitation, it requires high CPU and memory overhead. Performance 97% accuracies, and platform Windows and Linux endpoint. Hybrid cryptography. They used the approach deep learning, AlexNet plus crypto, and the strength you can say it is secure storage integration, overall improved the security system with the 99.89% accuracy in Android ransomware. But it is specifically for the mobile phone devices, and performance is very good in Android. Hard to generalize on another, maybe Windows or something like another platform. So now we can see platform specific applicabilities. We have surveyed some techniques, and let's see BTLS algorithm using only Windows, Linux enterprise system, but 97% accuracies. Ransomware using cloud computing with 99.5% precision, and hybrid crypto is with Android system 99.89%, and deepware Windows, Linux, and Mac. It requires 90. It's working with 98.6% recalls, and opcode analysis works with Windows, Linux, and cloud environment with 97% accuracy. So still, you can see there's a gap. There's a need of an approach which can work on all platforms. So every technique has some limited with some specific platform. So there's a need for the approach that can work on each maybe platforms. Yeah. Okay, so we have some comparative analysis. Cloud-based model. It offers high recall but requires a lot of computer power. And if you talk about the BTLS, it requires like balance cost and performance. But okay. And another is opcode analysis. It is early detection. It is good in early detection, but needs larger data set. And if you talk about the crypto plus deep learning, it is secure but platform dependent. It can work on only cloud or something. And if we talk about the static and dynamic integrations, It is improved in accuracy, but computationally expensive. So what next? So we have some current challenges. Let's see real-world deployment challenge involving aviation techniques, applications, and polymorphism, evade the detections, data set limitations, real-time detections, and cross-platforms. Let's see. The first one with the real-world deployment. Okay, so many enterprises use old system that can't detect, that can't support the AI models. And sometimes second is integration with existing cybersecurity tools, difficult to and costly to with integrations with these enterprises. And third is staff may lack training and understand to how act on AI based alerts. So what will be the solution? Solution could be like we can use a lightweight AI model to optimize architecture, could be use TNML or something. So it can be useful in this challenge. Second, we have evolving evasion techniques. Ransomware is getting smarter and can hide its real behavior. Sometimes it delays executions and avoid the detection in virtual environment, sandbox environment, or any something like maybe in dynamic analysis. So solution could be like uh, we can use to monitoring the time-based analysis and can apply adversarial trainings to expose the model and evasive techniques during the learning. Third, we have obfuscation and polymorphism. As I told you before, obfuscation changing the code inside and outside the structure. It can change slightly every time when it runs. This can trick the both static and signature-based detection tools. So the solution could be implement the code analysis and can be entropy-based detections. And another, we can train the model of variety of executive and polymorphism samples. If we train our model with these techniques samples, so it can be work well. Another, we have dataset limitations. Most public datasets are small, outdated, and incomplete. So it's a big challenge. We have to work on the dataset. Limited dataset makes the AI model less effective and against new threats. So what will solution? Solution could be like collaborate with the industry to build the shared data and can use the data augmentations for synthetic ransomware variants and can be regular dataset updates could be helpful in the recent attacks. And then we have real-time detection constraints. AI model needs high processing power and memory. So it's hard to run on the mobile devices because of the limited resources. So solution could be delegate the pre-processing to edge and the full analysis on the cloud. So it can be hybrid approach that can work. Could be a solution. Another, we have cross-platform challenge. Some models only work on Windows or Android. So sometimes it not work for the both. So we would need a universal model that works well for the multiple system. A solution could be like build a platform agnostic model using abstract features, or something like API calls or messages, ransomware messages, something like threatening message. Uh, Okay, so we have now complete the challenges. Now let's see how the future direction could be. The first one, adversarial defense. Techniques to protect the machine learning model for adversarial attack. Can be like adversarial training. Train the model will both clean and attacked data. Can be improved the adverseness. And if we talk about the input sanitization, we can detect and remove the adversarial noises before the processing. Can say image denoising. So if we can better the result in the image, can get better the results in the machine learning. Second, we have quantum computing. Of course, if we work detection things with the quantum computing, quantum can help to work with big data set and faster. Still theoretical but promising for the real-time system. Another we have hybrid model with federated learning. It can enable decentralized learning, preserve the privacy, and second and fourth we have cross-platform detection. Cross-platform detection, as I talked before, platform-specific model limited scalability. So our goal should be and would be like unify the framework for Windows, Linux, and Android, all platforms if we can work on. So could be a future work and can be better in ransomware detection. Okay, dataset expansion, the fifth one. Okay, include the IoT, mobile, and cloud samples could be helpful in the dataset expansion, and synthetic data generations can be helpful. Continuously updated repository could be helpful, and if we can work on these, so we can better our data. After we have some opportunities for collaboration, if we talk about academia, new research, new knowledge, and innovative solution can be helpful if the academia work on new research and new innovative solutions, and we can industry level we can like use these type of new research and new knowledge and new innovative solutions in the real world deployment, and government should like regulate the sport for the new technologies and can work on shared and benchmark shared data set and benchmark that can be helpful in the training and testing purpose. So the lastly we have conclusion. AI techniques outperform the traditional method in detection involving ransomware. And combining static and dynamic analysis with machine learning and deep learning, it achieves the highest results, but should we need to optimize it? And if we talk about the adversarial attack, ransomware now evades the machine learning model via input manipulations. And second is dataset security, lack of diverse and updated data limitation, limit the generalizations, and real-time demands computational cost, hinder the deployment on the edges. Technique shows the improves in accuracy, but needs some optimizations. So we talk about the future. We can work on adversarial defenses, dataset expansion, quantum AI. Thank you so much.